Montana Territory, autumn 1888. Raymond Keller was 41 years old, a former copper miner from Butte, who had spent 12 years working tunnels 1,000 feet below the surface. He understood something most homesteaders didn't: that temperature stabilizes with depth. That autumn, while his neighbors chinked their log cabins and stacked cordwood for winter, Raymond started digging beneath his barn floor. "You're wasting your time, Keller," master builder Jonas Millwright told him at the trading post. "Dirt don't keep you warm." Raymond kept digging. The problem wasn't whether it looked strange. Everyone agreed it did. The problem was that log cabins in the Flathead Valley burned cord after cord of wood and still let families wake to frost on the inside walls. Raymond had felt the constant 55 degrees of deep earth in the mines. He knew what that meant for winter survival. Raymond had returned to Montana Territory in 1886 after the Butte mines laid off half their crews. He brought his wife Catherine and their 2 children, Margaret, age 9, and Thomas, age 6. They had claimed a quarter section in the Flathead Valley, built a small barn, and planned to add a cabin in spring. But Raymond had seen 3 families freeze in their first winter. The Hendrick family, just 4 miles north, had lost 2 children to pneumonia in a cabin that burned wood day and night. The father had chopped and hauled and stacked until his hands bled, and it hadn't been enough. Raymond wasn't going to let that happen to his family. He started the excavation in late September. The plan was simple: dig 10 feet down beneath the barn floor, shore up the walls with fieldstone, install a timber ceiling, and live underground through the winter. His neighbors thought he was building a root cellar. When they realized he planned to move his family into it, the jokes started. "Building yourself a coffin house, Keller? Gonna bury your family before winter does it for you?" Raymond didn't argue. He kept digging. The soil was mostly clay with some rock. Hard work, but manageable. He hauled the dirt out in a wheelbarrow and piled it against the north side of the barn for extra wind protection. Catherine helped when she could, though she had her doubts. "Raymond, are you certain about this?" she asked one evening as they stood looking at the deepening hole. "I'm certain the Hendricks burned 60 cords of wood last winter and still froze," he said. "I'm certain we don't have 60 cords. And I'm certain the earth 8 feet down doesn't freeze." By mid-October, he had the excavation complete, 12 feet long, 10 feet wide, 10 feet deep. He started on the walls, gathering fieldstone from the creek bed and hauling it back in the wagon. Each stone had to fit tight against the next. No mortar, just careful placement. He'd learned that in the mines too, how to build a wall that wouldn't shift or crack when the earth pressed against it. The stone walls took 3 weeks. Raymond worked from dawn until dark, fitting stone after stone, building the walls up from the earthen floor. Catherine watched the calendar. Winter came early in the Flathead Valley. They needed to be sealed in before the first hard freeze. Jonas Millwright stopped by in early November. He climbed down the ladder, looked at the stone walls, shook his head. "You're gonna suffocate down here, Keller. No ventilation. No windows. This is a death trap." "There's a ventilation shaft in the corner," Raymond said, pointing to the narrow chimney he'd built up through the barn floor. "Draws air in through the door gap, exhausts through the shaft. Same principle as a mine tunnel." Jonas snorted. "You ever lived through a Montana winter in a mine tunnel?" "No," Raymond said. "But I lived through 12 years underground, and I never froze." Jonas climbed back up the ladder. At the trading post that afternoon, he told anyone who would listen that Raymond Keller was going to kill his family. Raymond installed the ceiling next. Heavy timber beams laid across the stone walls, then planks nailed perpendicular, then a layer of sod on top for insulation. The ceiling beams rested on the stone walls, not mortared, just gravity-held. The weight of the earth above would press down and lock everything in place. He left a trapdoor opening for the ladder and built a simple wooden frame around it. The floor was packed earth, smooth and level. In one corner, he built a small stone hearth with a chimney that vented up through the barn. It wasn't a big fireplace, just enough for a cooking fire and minimal heat. The real heat would come from the earth itself. By late November, it was ready. Raymond moved his family in. 4 wooden cots, a small table, a trunk for clothes, and a shelf for dishes. Catherine hung a blanket across one corner for privacy. Margaret and Thomas thought it was an adventure at first, like living in a cave. Then the first snow came, and the adventure turned serious. December started cold. Not brutal yet, but cold enough that the neighbors were burning wood steadily. Raymond used a small fire in the morning to cook breakfast, then let it die. By midday, the shelter was comfortably warm, somewhere in the high 50s. The stone walls held the earth's constant temperature, and the insulated ceiling kept it from escaping. Catherine stopped worrying. The children adjusted. Thomas liked that he could walk around in his socks without freezing. Margaret liked that the blankets didn't have frost on them in the morning. At the trading post, the jokes continued. "How's the mole hole, Keller?" someone would ask. Raymond would smile and say it was fine. He didn't mention the temperature. He didn't mention how little wood he was using. He let them think what they wanted. Jonas Millwright stopped by again in mid-December. He didn't come to check on Raymond. He came because his own cabin was burning through wood faster than he'd expected, and he wanted to borrow Raymond's wagon to haul another load from his woodlot. Raymond lent him the wagon. Jonas didn't ask to see the shelter. "Still alive down there?" Jonas said. "Still alive," Raymond said. "Wait till January," Jonas said. "That's when you'll know if it works." January came. On January 7th, the temperature dropped to 5 degrees below zero. The wind came out of the northwest, steady and brutal, driving snow horizontal across the valley. In the log cabins, families huddled near their fireplaces and burned wood as fast as they could split it. The wind found every gap in the chinking, every crack around the windows. Inside temperatures dropped into the 30s even with the fires roaring. In the underground shelter, Raymond woke to the same comfortable warmth he'd felt all December. He climbed the ladder, pushed open the trapdoor, and felt the cold slam into him. The barn above was barely warmer than outside. He climbed back down, closed the trapdoor, and the cold stayed above. Catherine cooked breakfast on a small fire. By mid-morning, the fire was out, and the shelter was still warm. The stone walls radiated the earth's steady 55 degrees. The insulated ceiling kept that heat from escaping. The air was still. No drafts, no wind. The small hearth had done its job and shut down. They didn't need it again until evening. Outside, the Hendrick family was burning wood every hour. Jonas Millwright's cabin was eating through his woodpile at a rate that terrified him. The McLaren family, 2 miles south, had run out of dry wood and was burning green pine that barely gave heat. Across the valley, families were burning furniture, fence posts, anything that would catch. Raymond used 1/10 of the wood his neighbors did. By January 15th, the cold had deepened. The temperature dropped to 12 degrees below zero at night and the wind never stopped. In the log cabins, ice formed on the inside walls. Children slept in coats and mittens. Fathers got up every 2 hours to feed the fires. In the underground shelter, Margaret and Thomas slept in their nightclothes. Catherine didn't worry about the fire going out. Raymond woke once each night to check the hearth, found it didn't need wood, and went back to sleep. On January 19th, Jonas Millwright ran out of wood. He had miscalculated. He thought he had enough to last until March, but the brutal cold and constant wind had doubled his consumption. He'd burned through his entire woodpile by mid-January, and his woodlot was snowed in, inaccessible. He tried to borrow from his neighbors, but they were all running low themselves. No one had extra. Jonas swallowed his pride and walked to Raymond's barn. Raymond was splitting kindling when Jonas arrived. Not much kindling, just enough for the day's cooking. Jonas looked at the small pile of wood beside the barn, looked at the faint smoke from the chimney, looked at Raymond. "How much wood you got left, Keller?" "Enough," Raymond said. "Enough for what? Till spring?" "Probably." Jonas stared at him. "You're burning a fraction of what I am." "I know," Raymond said. "I need to see it," Jonas said. "The shelter. I need to see how it works." Raymond led him to the barn, lifted the trapdoor, and gestured to the ladder. Jonas climbed down. Warm air met him halfway. Not hot air, not stove-heated air, but warm air, steady and comfortable. He reached the bottom and stood on the earthen floor. Catherine was mending a shirt by lantern light. Margaret and Thomas were playing a game with wooden blocks. No one was huddled near the fire. No one was wearing coats. Jonas touched the stone wall. It was warm. Not hot, but distinctly warm. Warmer than any cabin wall in the valley. He looked at the small hearth in the corner. The fire was barely glowing, just a few coals. Not enough to heat a room this size. Shouldn't be enough. "What's the temperature down here?" Jonas asked. "Mid-60s, Raymond said. "It varies a few degrees depending on how much we cook, but it stays in the 60s. Jonas did the math in his head. Outside was currently 9 degrees below zero. This shelter was 67 degrees warmer than outside. His cabin, with a roaring fire, was maybe 45 degrees warmer than outside. And that was when he was burning wood constantly. "How?" Jonas said. Raymond pointed to the stone walls. "The earth 8 feet down doesn't freeze. It stays at 55 degrees all year. These walls hold that temperature. The ceiling keeps it from escaping. We don't need to heat the space from 0 to 65. We only need to bump it from 55 to 65. That takes almost no wood." Jonas touched the wall again. He'd built cabins for 30 years. He knew wood, knew logs, knew chinking and fireplaces and chimney draw. He'd never thought about the earth as a heat source. Never thought about constant temperature at depth. "The earth's doing the work," Raymond said. "Not the fire." Jonas stayed for 20 minutes. He examined the walls, the ceiling, the hearth, the ventilation shaft. He asked about air quality. Raymond said it was fine, no stuffiness. The shaft drew well. Jonas asked about moisture. Raymond said the stone walls stayed dry, no condensation. Jonas asked about spring flooding. Raymond said the floor was 4 feet above the water table, well clear. Finally, Jonas climbed the ladder, stepped into the barn, and felt the cold hit him like a wall. He looked back down at the warm light glowing from the shelter, then at Raymond. "I was wrong," Jonas said. "I owe you an apology." "You were protecting people," Raymond said. "That's your job." "Can I tell others?" Jonas asked. "There are families burning their fences right now." "Tell them," Raymond said. Jonas walked back to his cabin, got his wife and children bundled up, and brought them to Raymond's barn. He showed them the shelter. They climbed down into the warmth, stood on the earthen floor, felt the stone walls. Jonas's wife started crying, not from sadness, from relief, from understanding that this could be built, that they could survive, that winter didn't have to mean burning everything they owned. Word spread fast. By the next day, 6 families had visited the shelter. By the end of the week, Raymond had sketched the design for a dozen homesteaders. The requirements were simple: dig 10 feet down, build fieldstone walls, install a timber ceiling with sod insulation, add a small hearth and ventilation shaft. Most families already had access to fieldstone and timber. The excavation was hard work, but manageable. The cost was labor and time, not money. Jonas Millwright became the design's biggest advocate. He helped the Hendrick family excavate beneath their barn in late January. He helped the McLaren family shore up their root cellar and convert it to living space. He showed people how to fit the stones, how to build the ventilation, how to calculate the depth. "I spent 30 years building cabins that barely work," Jonas said at the Trading Post. Keller spent 3 months building something that actually solves the problem. By March, 7 families in the Flathead Valley had built underground shelters. 3 more started excavations as soon as the ground thawed in April. The design spread to neighboring valleys. A trapper carried the story south to Missoula. A freight wagon driver took it north to the Canadian settlements. The shelters worked. Families that had burned 60 cords of wood in previous winters now burned 12. Children who had slept in coats now slept in nightclothes. Mothers who had worried about freezing now worried about normal things. The innovation wasn't magic. It was simple physics. Stable earth temperature plus good insulation plus minimal heating equals comfort. Jonas Millwright's transformation was the most remarkable. He'd spent 3 decades building conventional cabins, defending his methods, dismissing alternatives. When Raymond proved him wrong, Jonas didn't double down. He admitted error, learned the new method, and taught it to others. At 62 years old, he rebuilt his understanding of how to keep people warm. "I thought I knew everything about cabins," Jonas said that spring. "Turns out I knew everything about one type of cabin. Keller showed me there's another way." Raymond's shelter remained in use through the spring. When warm weather arrived, the family moved back into the barn's upper level for better ventilation. But the shelter stayed ready. The next winter, they moved back down. And the winter after that, the Hendrick family used their shelter for 8 winters. The McLaren family used theirs for 12. Several families built their permanent homes on top of their shelters, using them as basements and root cellars after installing better above-ground housing. The physics didn't change. The earth still provided constant temperature at depth. The stone wall still held that temperature. The principle remained sound. By the mid-1890s, underground and semi-underground shelters were common enough in Montana Territory that they stopped being remarkable. New families arriving in the valley asked about them. Local builders included them in standard homestead planning. The technique had moved from radical experiment to accepted practice in less than a decade. Raymond's original shelter remained in use until 1904. That year, he built a proper 2-story house on his property, with a modern basement that incorporated many of the original shelter's principles. Deep foundation, fieldstone walls, good insulation. The old shelter beneath the barn became storage space, then gradually filled with tools and equipment as the barn itself aged. Jonas Millwright lived until 1911. In his final years, he told anyone who would listen about the winter he'd been wrong. "Best lesson I ever learned," he'd say, "came from a miner who understood dirt better than I understood wood." Catherine Keller kept detailed household records throughout her life. Her journals, preserved by her granddaughter, show the wood consumption data clearly. In the winter of 1887–1888, before the shelter, the family burned approximately 48 cords of wood and still suffered through cold nights. In the winter of 1888–1889, in the shelter, they burned 6 cords. The reduction wasn't an estimate. It was measured, recorded, and verified. Margaret Keller, Raymond's daughter, married a homesteader from the Bitterroot Valley in 1899. She helped him build a semi-underground shelter on their property before their first winter. Her children grew up warm. When asked about it years later, she said, "My father understood something simple. Work with the earth, not against it." Thomas Keller became a surveyor and eventually a civil engineer. He worked on railroad projects across Montana and Idaho. In his professional work, he consistently advocated for earth-sheltered structures in remote locations. His reports cited his childhood experience living underground as proof of concept. The technique's spread beyond Montana was limited by geography and culture. In regions with high water tables or rocky soil, excavation was impractical. In areas with milder winters, the investment wasn't justified. In communities with strong architectural traditions, the design seemed too radical. But in the mountain territories, the northern plains, and isolated valleys where winter was brutal and resources were scarce, earth-sheltered structures became part of the building vocabulary. Some families improved on Raymond's basic design. The Peterson family in Wyoming built a shelter with a south-facing entrance that captured solar heat during the day. The O'Malley family in Idaho used native stone for the walls, but added a layer of sheep's wool insulation against the ceiling for extra warmth. The Chen family, Chinese immigrants working the Montana railroads, incorporated principles from traditional Kang heated sleeping platforms into their shelter design. Each variation worked. The core principle remained constant, stable earth temperature, plus insulation, plus minimal heating, equals comfort and efficiency. The families who understood this survived winter with less wood, less labor, and less fear. By the 1920s, improved transportation and cheaper fuel began changing the economics of frontier heating. Coal became available in regions that had relied on wood. Kerosene heaters offered convenient supplemental heat. Better insulation materials made conventional above-ground homes more practical. The homestead era was ending, and with it, the desperate innovations that had defined it. Raymond's shelter was demolished in 1928, when the barn collapsed during a heavy snow. The new owner of the property, Raymond's nephew, chose not to rebuild. He filled in the excavation and leveled the site. The fieldstone walls were salvaged for a garden wall. The timber ceiling beams were reused in a shed. Within a year, no visible trace of the shelter remained. The knowledge didn't disappear immediately. Older families remembered. Children who had grown up in earth-sheltered homes told their own children about it. But as those generations passed, the details faded. By the 1940s, most people in the Flathead Valley had never heard of Raymond Keller or his underground shelter. The story survived in family records, and a few journal entries, and occasional mentions in county histories. Jonas Millwright's grandson, interviewed in 1956 for a local history project, remembered his grandfather talking about the miner who built underground. He remembered the basic concept, but not the technical details. He remembered that it had worked, but not why. The story had become an anecdote, stripped of its practical content. That's what happens to knowledge when it's not written down systematically. The story survives, but the engineering doesn't. People remember that something worked without remembering how to build it. Before any modern application of historical building techniques, consult with licensed professional engineers, architects, and building inspectors. Historical methods provide valuable insights into practical physics and resourceful problem solving, but they must be adapted to meet current structural codes, safety standards, ventilation requirements, and local regulations. Underground construction involves specific challenges: soil stability, water table management, proper drainage, structural loading, emergency egress, and ventilation that meets modern air quality standards. What worked for a Montana homesteader in 1888 cannot be directly copied today without professional design review and proper permitting. The principle, however, remains valid. The earth at depth maintains a stable temperature. Proper insulation retains that temperature. Minimal heating can maintain comfort when the baseline is 55 degrees instead of 0. These are facts of physics, not historical curiosities. Raymond Keller died in 1921 at the age of 74. His obituary in the Flathead County newspaper mentioned his mining career, his homestead, his children and grandchildren. It did not mention the shelter. By then, it was just one of many things he'd built, not particularly remarkable in the context of a full life. But for one winter, in 1889, when the temperature dropped to 21 degrees below 0 and the wind never stopped, that shelter was the difference between survival and suffering. For 7 families who built their own versions, it was the difference between burning everything they owned and having wood left in spring. For Jonas Millwright, it was the difference between being right and being wise. The story teaches a simple lesson. Knowledge from unexpected sources can solve problems that conventional wisdom cannot. Raymond wasn't a builder. He was a miner. He understood earth and temperature from a completely different context. When he applied that understanding to a housing problem, he found a solution that professional builders had missed. The valley laughed at his underground shelter. They called it a mole hole, a coffin house, a death trap. Then winter came, and it stayed 68 degrees inside, while the temperature outside dropped to 21 below 0. The mockery stopped. The copying started. Sometimes the ridiculous idea is the right one. Sometimes the expert is wrong. Sometimes the answer comes from someone who thinks differently because they learned in a different place. Raymond Keller understood dirt. That understanding kept his family warm when everyone else was freezing. That's not folklore. That's documented, measured, verified fact. The shelters that followed proved the principle worked at scale. 7 families the first winter, 15 by the second winter, dozens across Montana territory by the mid-1890s. Each one demonstrated the same physics: constant earth temperature, good insulation, minimal heating. Each family reduced their wood consumption by 70 to 85%. Each family slept warmer, worried less, survived winter with resources left over. Jonas Millwright built 3 earth-sheltered structures in the decade after he visited Raymond's shelter. He incorporated the principles into conventional construction, adding deeper foundations, better insulation, and thermal mass storage. His later cabins used half the wood of his earlier designs. He never stopped building above-ground homes, but he changed how he thought about them. That's the legacy, not just the shelters themselves, but the change in thinking they represented. Before Raymond's shelter, frontier builders focused on heating the air. After Raymond's shelter, some builders started thinking about retaining temperature. The shift seems subtle, but it changed fuel consumption dramatically. The families who used earth-sheltered structures through the 1890s and early 1900s gained an advantage in harsh winters. They allocated less labor to wood cutting and hauling. They had more time for other work. Their children grew up healthier because they weren't exposed to constant cold stress. The economic and health benefits compounded over years. By the 1920s, those advantages mattered less. Modern heating, better materials, and improved transportation reduced the survival pressure that had driven the original innovation. The earth-sheltered homes were gradually abandoned or repurposed. Some became root cellars. Some became storage. Some were filled in and forgotten. The knowledge survived longest in the most remote locations. In valleys where winter was still brutal and resources still scarce, families maintained earth-sheltered structures into the 1930s. The Miller family in the Bitterroot Valley used their shelter until 1934, when rural electrification reached their property and made electric heating practical. The Swenson family near the Canadian border kept theirs operational until 1938, using it as a winter workshop, even after they'd built a modern home on the property. These late survival examples demonstrated something important. The technique worked regardless of decade. The physics hadn't changed. Earth temperature at depth in 1938 was the same as Earth temperature at depth in 1888. The principle remained valid even as the surrounding technology evolved. Some families tried to preserve the shelters as historical structures. The Hendrick family maintained their original 1889 shelter until 1947, using it for cold storage and showing it to visiting relatives as a curiosity. But maintenance was constant. Stone walls needed repointing. Timber ceilings needed shoring. Ventilation shafts needed clearing. Without active use, the structures deteriorated quickly. By 1950, most of the original earth-sheltered homes built in Raymond's era had been demolished or filled in. A few survived as basements beneath newer construction. A handful remained as root cellars or storm shelters. But the specific design, the TheFieldStone walls, the timber ceiling, the minimal hearth, the ventilation shaft, had largely disappeared from the Montana landscape. The disappearance wasn't tragic. The shelters had served their purpose. They'd kept families alive through winters that conventional cabins couldn't handle. They'd provided warmth with minimal resources during an era when resources were desperately scarce. When better solutions became available, people moved on. That's practical adaptation, not cultural loss. What was lost was the systematic understanding of why the shelters worked. The physics knowledge didn't transfer to the next generation in a usable form. People remembered that underground homes stayed warm, but they didn't retain the specific principles. Constant earth temperature at 8 to 10 feet depth, thermal mass storage in stone walls, insulation at the ceiling to prevent heat escape, minimal heating to bridge the gap between 55 degrees and 65 degrees. Without that systematic understanding, the technique couldn't be adapted or improved. It remained frozen as a historical anecdote rather than evolving into a modern practice. Raymond's own family history illustrates this. His daughter Margaret understood the shelter worked and helped her husband build one. Her son, Raymond's grandson, remembered playing in the shelter as a young child, but never learned how to construct one himself. Her grandson, Raymond's great-grandson, knew only that great-grandfather built something underground during the homestead days. The technical knowledge degraded across 3 generations. That degradation happened to countless practical innovations across the frontier era. Techniques that solved real problems were practiced successfully, then forgotten when circumstances changed. The knowledge existed in action, but not in documentation. When the action stopped, the knowledge evaporated. Jonas Millwright's building records provide one of the few documented exceptions. He kept detailed construction notes for every project, from 1892 until his retirement in 1908. Those notes include measurements, material specifications, and performance observations for 6 earth-sheltered structures he helped build. The records survived because his son donated them to the Flathead County Historical Society in 1923. They sit in an archive box, available to researchers but rarely consulted. The broader historical record is sparse. County building records from the 1880s and 1890s rarely distinguished between structure types. Census data recorded dwelling, or house, without specifying construction method. Tax assessments noted property value, but not architectural details. The shelters existed in the gaps of official documentation. Personal letters and journals provide the best evidence. Catherine Keller's journals. The Hendrick family correspondence. A handful of homesteader diaries that mention the underground homes or the miner's shelter design. These scattered sources confirm the timeline, the geographic spread, and the basic functionality. But they don't provide construction blueprints or engineering specifications. That's the frustration of historical research. We know these structures existed. We know they worked. We have measurements and testimonials. But we don't have complete technical documentation that would allow direct replication. Modern earth-sheltered housing exists, of course. Contemporary architects and engineers design underground and partially underground homes using current materials, modern ventilation systems, and professional structural analysis. These designs incorporate principles similar to Raymond's shelter: stable earth temperature, good insulation, minimal heating, but they're built to current codes with current technology. The connection between Raymond's 1888 shelter and modern earth-sheltered design is conceptual, not direct. Modern builders didn't rediscover the technique by reading about frontier Montana. They rediscovered it by understanding the same physics Raymond understood: that the earth maintains constant temperature at depth, and that constant temperature provides a massive advantage for climate control. The principle keeps being rediscovered because it's fundamentally sound. Every generation that faces heating costs, energy efficiency concerns, or climate control challenges eventually considers, what if we built underground? The answer is the same, whether you're a copper miner in 1888 Montana or a sustainable architect in the 21st century. It works, if you understand the physics and engineer it properly. Raymond Keller didn't invent underground housing. Humans have built below ground for thousands of years. What Raymond did was apply underground principles to a specific frontier problem: how to survive Montana winter with minimal resources. His solution wasn't theoretical. It was practical, immediate, and measurable. 67 degrees warmer than outside. 85% less wood. A family that stayed healthy through brutal cold. The valley laughed, then copied, then forgot. That cycle repeats throughout history. Innovation appears strange until it proves effective. Once it's proven, it spreads. Once it's no longer necessary, it fades. The forgetting isn't failure. It's just change. But the physics doesn't fade. The Earth still maintains stable temperature at depth. Stone still stores and radiates thermal mass. Insulation still prevents heat escape. These facts remain constant across centuries. When circumstances make them relevant again, they're waiting to be reapplied. That's what Raymond understood in 1888. That's what Jonas Millwright learned when he climbed down the ladder into unexpected warm winter, and Montana still drops to 20 below. The wind still finds every crack. Families still face the question of how to stay warm without burning through everything they own. The problems Raymond Keller solved in 1888 haven't disappeared. They've just been postponed by cheap energy and modern materials. When those resources become expensive or scarce again, the old questions resurface. How do you heat a space efficiently? How do you work with natural systems instead of fighting them? How do you build for survival, not just comfort? The answers Raymond found aren't obsolete. They're dormant. The Earth still holds 55 degrees at 10 feet down. Stone walls still store thermal mass. Insulation still prevents heat loss. These aren't historical curiosities. They're physics principles that work regardless of century. Jonas Millwright figured that out in January 1889. When he climbed down a ladder into warmth he couldn't explain with 30 years of building experience. He touched a stone wall that shouldn't have been warm, and realized his entire understanding of heating was incomplete. The Earth was doing work he'd never accounted for. That realization changed how he built for the rest of his career, not by abandoning conventional construction, but by incorporating principles he dismissed as impossible. Deeper foundations, better insulation, thermal mass where it mattered. His later cabins weren't underground, but they borrowed the physics that made underground work. That's the practical legacy, not the specific shelters, but the thinking they represented. Work with natural systems. Understand the baseline temperature. Insulate what matters. Heat efficiently, not desperately. Raymond's shelter kept his family warm through 6 Montana winters. Then they moved into a better house, and the shelter became storage. Eventually it was demolished and filled in. The story should end there, with practical innovation serving its purpose and then fading away. But the story doesn't end. It waits. Somewhere in a Montana valley, the Earth still holds 55 degrees at 10 feet down. The physics that kept Raymond's family warm in 1889 still works. The principle is still sound. The knowledge is still valid. Someone just needs to remember it.